data science is a combination of dealing with the data plus domain expertise, because that's very, very important concept which with of late data scientists we look for, right? We need person who understands domain. For example, you're working on an insurance sector, you're working on a banking data, so you should know what to remove, what not to remove from the whole data set. You cannot just remove whatever we want. That's why we have the domain experts in place.
So in general, you should not use a categorical variable, okay, in a scatter plot, okay, because obviously you will see such wall figures, okay, which is not really a good visualization to observe. But when you have a category which is more like an ordinal, because it has an order grade 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, and many categories in that order, you can try and do a scatter plot also to do some visualization, okay, but not the best thing again to do. Best way is to basically do a box plot by group for this also.
Relative position, okay, do you know about these things, measure of relative position? Right, so things like percentile, quartile, okay, we call them as a measure of the relative position of data, okay. So if let's say in an examination, I got 68 marks, right? Now I want to know what is my percentile score, or if I want to know in which quartile I am in, which means I am asking what is my relative position, okay. With 68 marks, I could be the topper in the class, okay, that means I am in the top percentile, right? But at 68% marks, I could be failure in the class as well, okay. So how would I know what is my relative position? That is something you got from the percentile and quartile, okay. And probably you might have also learned about measure of shape of data, which is nothing but skewness and kurtosis. Skewness I would use, okay, so if you give me a data and if I want to find out whether the data is symmetrically distributed, then I would check the skewness in the data. If the skewness is 0, that means my data is symmetric, okay. And based upon these the property of the data, I can better pick a model, okay, or I can better pick an approach to treat the data.
One of the other areas that we're looking at is in terms of your customer relationship management. Now, how do you look at? You look at the social network data. Why do I look at the social network data? Okay, fine. How do I find out a potential customer? Whether this person will be able to afford a premium or will not be able to afford a premium, I can look at the social network data and I can find out. So what we do is we look at the listening. We look at we have a kind of a listening tool. And then we look at your customer profile, history, transactions. We can do all that. And based on the business rules, combine them with the decision-making process, where you can find out, the insurance is able to find out based on the social customer relationship management. It's able to find out whether it's a genuine claimant or a fake claimant. It can be a good customer or a bad customer. So based on these, by the way, these things are being looked at by the various insurance companies. So it's no more fantasy land we're looking at.
This diagram shows what a Poisson distribution looks like at different values of lambda. So as you can see, it's more or less a symmetrical distribution. The first one looks a bit awkward because it's so close to 0. But if it could go into negative, it would be a symmetrical there also. So this is a Poisson distribution. An exponential distribution, on the other hand, looks like this. As you can see, they start off at a very high peak and then they taper off. This is what an exponential distribution looks like. As for knowing which of the two you're dealing with, the only way to know that really is to look at the raw data. You look at the raw data and put it up on a chart. If it's a symmetrical distribution, you're looking at a Poisson. If it's a right skewed distribution, you're looking at an exponential distribution.
What is linear regression? Linear regression is a type of modeling exercise, right? So when we say word modeling, what do we mean? We mean we are establishing a relationship between dependent variable and independent variable. So for example, right, our dependent variable can be, let us say, amount spent by a customer in a particular company. right? So that is a continuous variable. And then we'll have independent variable. Independent variables are factors which are responsible for amount spent, right? Now, what will amount spent depend on? It might depend on household income, it might depend on salary, it might depend on number of children in the house, number of credit cards owned, number of bank transactions carried out. So many things, right? So hundreds of factors it will depend on. So we have a dependent variable, amount spent. We have independent variables. All right. Now we can establish a relationship between dependent and independent variables as y predicted is equal to beta naught plus, pardon my legibility because I'm typing it out in the system, right? So it won't be as neat, but I'll try my best. Okay. Beta 1 x1 plus beta 2 x2 plus beta 3 x3. So this is what modeling's output is, right? We'll get a equation. When we say modeling, what does it mean? We establish a relationship between dependent and independent variables.
So coming to the important aspect, when you, from an industry perspective, for all you aspiring data scientists, what are the different roles that you can play? And within an organization, this is what are the top roles. Now, it can be a data-oriented role. When I say data-oriented roles, you're working towards the engineering of the entire data, what is called as analyst or information management. Now, you can become a data engineer, you can become a data architect, how exactly the entire governance of the data has to be, what should be the enterprise architecture, and how exactly this data is going to be stored, how the jobs has to be running. And also I will actually put in visualization over here and BI, how does the reporting happen? How do we visualize this particular data? And that's one set of the roles that a particular guy can do it. Second is core modeling, the data scientists, ML engineers. So the job roles that these guys do is once the data comes in, they know what the problem is. They start building the models and they're going to do the entire modeling aspects. Now, once these models are done, they start thinking of deploying these things. And that's the bulk of the people where most of the folks are peaking. And then is a little bit of business-oriented roles in this entire genre, and what we call as analytics translators. You understand a business problem and convert it into an analytics problem. That's the thing. And there are managerial roles. So if you go to any third-party consulting companies, so after a certain level of, you have moved up, you can either become a people manager, wherein you are handling a big team of analytics folks, data scientists, data engineers, and so forth. You understand business as well. And when I say business, the industries. So you understand how the banking works, what are the major challenges, what is the kind of data, and you convert and get the stuff delivered by core data scientists and everyone. Or you can work as a business development side, which is how do I sell AI ML services? How do I sell AI ML products? So these are the three different kind of big broad set of roles that are being available in an organization.